What's up, my little bowls of caramel praline ice cream? We are on our very last lesson for Unit 5. Today, we are going to learn how to make our stupid pen work. No, we're not. I'm probably never going to learn that. But today, what you're going to learn is how to solve rational equations. And you're going to say, Mr. Barton, has that not been what I've been doing this entire time? What do you mean now I learned solving equations? What have I been doing this whole time? All you've learned how to do so far is multiply, reduce, add, and subtract them. Now, we're going to take expressions, which is like 3x minus 2 minus x minus 2 over x plus 3. This is what you've been doing. What we're going to do today is we're going to say that this equals x plus 12 over x. And we're going to figure out what values of x make this true. Okay. It seems like a very daunting task, and that's because it can be a little bit. It's a little bit much on some of the problems, but don't worry. You guys are big kids who are very determined to do well in school, who care a lot about your math class, and who want to be successful later in life. And you know that you can't be a mechanic if you can't solve rational equations, and you definitely can't do roofs or work construction or be a baker if you can't do rational expressions. Haven't you ever seen the really good English baking show where they do this stuff all the time? It's a necessity. So we've got to learn it. You're going to just have to put on your big kid britches and suck it up and learn to solve them. So let's go. So we're going to start with solving proportions. What this means is you're going to have one fraction equals another fraction, and you're going to solve that. You're going to figure out what values of x you're supposed to use to make that true. To do this, you're going to cross multiply. This is another thing that you probably learned in like 3rd or 4th grade. So you multiply the a and the d together to get AD, and then you set that equal to the c times the b. Okay? Then it will be solvable. Let's talk about the steps you're going to need to follow to do this, though, because if it were that easy, I wouldn't need to teach it to you, right? I could just hand you the homework and you would say, this is easy, obviously. So, some steps. We need to start by finding our restrictions. We might need to do a little bit of factoring in order to do this. But I believe in you. I think you can do it. After we get the restrictions and we write them down, we're going to do our cross multiplying. You might need to FOIL or distribute, but that's fine. You guys are big kids and you can do that. Then you're going to solve for x. So you're going to have like x plus 3 equals 2x plus 6 or something. This one probably actually won't work, but well, actually it probably would. You're going to do this, and then you're going to get all the x's on one side, you're going to get all the numbers on the other, and you'll find x. If you have an x squared, you're going to need to factor. So if your solutions, so you're going to get some answers here. If one of these answers is one of the restrictions, you throw it away because it is an extraneous solution. So it's no longer an answer. You throw it away. Some blah, blah, blah. Okay, so it just says we got to check our answers because some of them are extraneous. So let's go ahead and go try some. All right. So these are going to be like the absolute easiest. Oh, no. What's going on? Oh, no. Hang on. My computer's all messed up. Let me try this one more time. Sorry, emergency. You guys can't see the emergency, but it's fixed now. Why do you have a little thing on the side now? That's so weird. All right, fixed. Sorry, we had a small emergency there. All right, for these questions, these are some of the easiest questions you're going to get. It just says, determine if the given value is a solution. So you just have to plug in the number they give you and figure out, does it work or not? So let's go ahead and try it on this one right here. So it says c equals -3. So we're going to take -3 and we're going to plug it into that c and that c. And if we get something like 5/2 equals 5/2, it works. If we get something that either breaks or is not equal, it doesn't work, and we'll say that it's an extraneous solution. So plugging in -3, we're going to get 5/-3 equals 2/-3 plus 3. We need to simplify this. We get 5/-3 equals 2/-3 plus 3 is 0. Okay. Are these equal? No, they're definitely not. The other big issue is here, we're dividing by 0. This is absolutely forbidden. Like the dark magic gods have said in the 10 commandments of math, thou shalt not divide by 0 lest thou I don't know. I'm not good at Bible stuff, but you know what I mean. You can't do it. It's against the rules. So for this one, we would just say that c equals -3 is not a solution. Cool, easy peasy. All right, let's try this one. So we're going to plug in 4 for x. So that should be pretty easy. 2/4 plus 3 plus 3/2 equals 19/10. All right, 4 plus 3, that's 7. So 2/7 plus 3/2 equals 19/10. All right, it's hard to tell if this is true yet. What we have to do is add these two fractions together by finding a common denominator. So what's the least common multiple of 2 and 7? 14. So we're going to multiply this one by 2 on the top and the bottom, and this one by 7 on the top and the bottom. So we get 4/14 plus 21/14 equals 19/10. Add your like terms here. We get 25/14 equals 19/10. Can we reduce? No, there's no common factor between 25 and 4. So because these are not equal, we can say that x equals 4 is not a solution. Okay, not too bad. Now let's actually solve our own. And you're going to say, Mr. Warren, we didn't get one where it was a solution. All right, well, that's what we're going to do right now. Don't trip. So it says solve for x, check for extraneous solutions. So we're going to cross multiply, but our first step before we can do that is we need to get our restrictions. So let me write restrictions. Let me copy this so that I don't have to write this 1,200 more times. And the way we get restrictions is the same way we've always gotten restrictions. We're going to set the denominators equal to 0, and then we're going to solve for x. So here, we subtract 7 on both sides. These cancel. 2x equals -7. Divide by 2. X equals -7/2. So that's one of our restrictions. X does not equal -7/2. Here we just add 1. That's pretty easy. X equals 1. So x does not equal 1 is a restriction. There we go. All right. Now we need to do our cross multiplying and solving for x. So here we're going to cross multiply these. So we're going to have x times x minus 1 equals cross multiply these. 2x plus 7 times x minus 5. Here we can just distribute the x in. So x times x is x squared. X times -1 is -x. Equals, here we have to FOIL. So 2x times x is 2x squared. 2x times -5 is -10x. 7 times x is 7x. And 7 times -5 is -35. Now we can combine our like terms here. -10 plus 7, that's going to be -3x. We have 2x squared minus 3x minus 35 equals x squared minus x. Now, because we have x squareds, what we need to do is move everything to one side and then factor and then set those factors equal to 0. So we're going to move everything over to there because that's where the bigger x squared is, and we want to stay positive. So let's subtract x squared and add x. Subtract x squared and add x. So this side cancels and we get 0 equals 2x squared minus x squared is just 1x squared. 3x plus x is negative 2x. And then bring down our negative 35. Now we need to factor this. So we need two numbers that multiply to negative 35. So we look at our factors of 35. 1 times 35. And then 5 times 7 are the only other ones. We need to make a negative 2. So we're going to do negative 7 plus 5. So this is going to be 0 equals x plus 5 and x minus 7. Okay, we're almost done. We finished factoring. Now we just set our factors equal to 0, and those are the answers as long as they're not also restrictions. So x plus 5 equals 0. Subtract 5. X equals negative 5. X minus 7 equals 0. Add 7. X equals 7. And these are our two solutions. But let's check our restrictions. Our restrictions are x does not equal negative 7 over 2 or 1. That is neither of these. So these are actual solutions. These are correct and they work, so we're good to go. All right. Let's do two more just for practice. So we need to find our restrictions for this one first. So let's put, restrictions. All right. So we need to set x minus 4 equal to 0. X minus 4 equals 0. Add 4. These cancel. X equals 4. So x does not equal 4 is our restriction. We don't need to worry about the 5 because 5 can't equal 0, so it can't be a restriction. So now that we have our restrictions, we're going to go ahead and cross multiply. So 2 times 5, we can do that in our head. That's 10. Equals x minus 4 times x plus 5. All right. On this side, we have the FOIL. So x times x is x squared. X times 5 is 5x. Negative 4 times x is negative 4x. And negative 4 times 5 is negative 20. Equals 10. Because we have an x squared, we need to move everything to one side so it equals 0 and then factor. So we're going to subtract 10 to get over here with the rest of our stuff. So these cancel. 0 equals x squared. 5x minus 4x is just x. And then negative 20 minus 10 is negative 30. So now we look at 30 and we find its factors. So 1 and 30, 2 times 15, 3 times 10, and then 5 times 6. We need to get a positive 1, and they need to multiply to a negative 30. So we're going to use positive 6 and negative 5. So we have 0 equals x minus 5 and x plus 6. Negative 5 times 6 is negative 30, and negative 5 plus 6 is 1. So we're good. Now we just set these equal to 0. So x minus 5 equals 0. Add 5. These cancel, and x equals 5. X plus 6 equals 0. Subtract 6. X equals negative 6. Check your restrictions. Can't be 4. Neither of these are 4, so we get to keep both of them, and they are solutions. All right. Let's do one more example. I'm going to erase all this work so we don't get distracted. If you need to see it again, just rewind the video. All right. Our restrictions. So for our restrictions, we're going to set these equal to 0. So 4 minus x equals 0. We want x by itself and to be positive. So let's just add x. So 4 equals x. So x cannot be 4 again. And then x minus 4 equals 0. Add 4. Oh, it's the same thing again. X equals 4. We already have that restriction. We have to check, though, just because these are different, right? This is positive 4, this is negative 4. They're different. We should still check. Sometimes they'll get ones like this where they look very similar, but they don't quite give you the same restriction. So you need to be careful with them. All right. Now we do our cross multiplying. This won't be too bad because we're going to have monomials, so we can just distribute. So 2x times x is 2x squared, and then 2x times negative 4 is negative 8x, equals x squared times 4 is 4x squared, and then x squared times negative x is negative x to the third. All right. Now, we want our leading term, our term with the biggest exponent, to be positive. So I'm going to move these over so that this changes sign and becomes positive. So let's subtract 4x squared. And let's add x cubed. So this side cancels and equals 0. This x cubed doesn't have any other x cubes to add to, so we just bring it down. 2x squared minus 4x squared is negative 2x squared. Bring down our negative 8x. All right. Now to solve this, we need to factor it and set all the factors equal to 0. So let's start by taking out our GCF of x. So we're going to have x. We had 3, we took one out. Now we have x squared. Took one out of here, so now we have x. Took one out of there. Now we have 8 equals 0. Now we factor this. So we look at the factors of 8, and we need 2 that are going to add up to negative 2. So we've got 1 times 8 and 2 times 4. So we're going to use negative 4 and positive 2. We have x times x plus 2 times x minus 4. This equals 0. And now we set all of these equal to 0 to get our solutions. All right. So x equals 0, that's solved. X is by itself. That's the solution. That was easy. Subtract 2 here. X equals negative 2. And then add 4 here. X equals 4. So now we look. X cannot be 4, though. So what that means is that this solution is extraneous, and we throw it out. It's not a solution. These are the two solutions, x equals 0 and x equals negative 2. All right. So they're solving if we have a fraction equals a fraction. Unfortunately for you, it's never going to be quite that easy. So we're going to have to solve rational equations. This is if we have more rational expressions, meaning we have multiple fractions on one side. That's what we're looking at now. So the steps for this are very, very similar. Start by identifying your restrictions. Then we're going to need to add the two fractions that are on the same side of the equation. We're going to have to stick them together and make one fraction out of them. We're going to do that by finding a least common denominator and then adding or subtracting like it says. We're going to cross out the denominators of the entire problem. I'll show you that step and kind of explain why in a moment. And then we'll solve the resulting equation for x. We might need to do some factoring, but it'll be okay. So we'll check our solutions against the restrictions and determine if there are any extraneous ones. So, all right, let's look at this. So what we want to do is add these two fractions here. Okay. So what we can do is, oh, actually, I'm sorry, I'm skipping ahead. We need to find our restrictions first. So we set this equal to 0, x equals 0. Okay, that's a restriction. So x cannot be 0 is one of our restrictions. Then we set this equal to 0, x plus 1 equals 0, subtract 1, x equals negative 1. So x does not equal negative 1 is a restriction. And then these are the same, so we get rid of that. All right. Now what we want to do is make all three fractions have a common denominator. The reason for that is so that we can do this crossing out later. If we don't make them all have a common denominator, then it's not going to work. And you're going to say, Mr. Barn, I'm only trying to add these two. Can't I just do these two? Well, you can, but then you have to do the problem in a different way, and that way makes it a little more work. So it's actually easier to just do all three. So let's look what they have. This fraction has an x and an x plus 1. This fraction has an x plus 1. So we need to put the x by itself on it. So x times x. This fraction does not have the x plus 1, so we need to multiply by x plus 1 on the top and the bottom. All right. So here, this won't change. 3 over x times x plus 1 plus 3 times x is 3x over x times x plus 1 equals, this negative will keep with the 1. So negative 1 times x is negative x. Negative 1 times 1 is negative 1 over x times x plus 1. And you're going to say, Mr. Brown, why don't you multiply the bottom? We're going to cross them out anyway. So if I'm just going to cross them out, I'm not going to go through all the work of just, multiplying them. Here's why they cross out. Or actually, pardon me, sorry. I'm getting anxious and getting ahead of myself again. Let's add these two fractions here. So 3 plus 3x. These aren't like terms, so we keep them separate. 3x plus 3 over x times x plus 1 equals negative x minus 1 over x times x plus 1. All right. Now, instead of cross multiplying, what we're really going to be doing is multiplying both sides by the denominators. We're going to multiply by x times x plus 1. And we're going to multiply by x times x plus 1. What that does is this cancels the bottom, and this cancels that bottom. So the denominators just go away. And now we don't have to do all that FOILing. So we just have 3x plus 3 equals negative x minus 1. And this is a lot easier than cross multiplying. If we cross multiplied, we'd have some big, ugly, nasty thing with really high powers. And that would make our lives just so hard. So we're going to just cross them out instead. So from now on, what I'm going to do is I'm just going to cross out the denominators, but understand we're multiplying both sides by the denominator and they cancel. Now, to solve this really easy problem, all we have to do is move all the x's to one side, move the numbers to the other, and simplify. So we're going to add x. These cancel. We get 4x plus 3 equals negative 1. Subtract 3. And we have 4x equals negative 4. Divide by 4. X equals negative 1. This is our answer. Let's check our restrictions. X cannot be negative 1. So this is getting thrown away because it's extraneous. So that means we don't have any solutions left. So for this problem, there is no real solution. And there we go. All right. Let's do a couple more just to make sure you got it. All right. So let's start by factoring this so that we can get our restrictions. We'll look at the factors of 10. They are 1 times 10 and 2 times 5. And then we're going to use positive 5 and negative 2 to get 3, and those multiply to negative 10. So this is going to factor to x minus 2 and x plus 5. All right. Now, we need to get our restrictions. So we're going to set these equal to 0. This. These three are all the same, though. So we can just do it one time. So x minus 2 equals 0. Add 2. X equals 2. So x does not equal 2 is a restriction. Same thing with the x plus 5. X plus 5 equals 0. Subtract 5. And then x equals negative 5. So x does not equal negative 5 is a restriction. So those are our restrictions. All right. Now, we need to make all of our denominators match again. So what we're going to do is we're going to multiply by x plus 5 because all of them already have the x minus 2. So that's good. This fraction and this fraction need the x plus 5. So we're going to put x plus 5, x plus 5, x plus 5, and x plus 5. All right. So here, 2 times x is 2x. 2 times 5 is 10 over x minus 2 times x plus 5. Again, I'm not going to multiply the bottom out because we're just going to cancel it later anyway. X times x is x squared. X times 5 is 5x over our matching denominator, x minus 2 times x plus 5 plus 6, and this one's not changing, x minus 2 times x plus 5. All right, now we need to add our like terms here. So this will stay the same, 2x plus 10 over the matching denominator. I'm not going to bother writing it just because it's going to get canceled out in a second anyway, and we don't really care what it is. X squared plus 5x plus 6. None of these are like terms, so they'll just be x squared plus 5x plus 6 over our matching denominator. We multiply by the matching denominator on both sides, and they cancel. So now we have 2x plus 10 equals x squared plus 5x plus 6. Now we have an x squared again, so we need to move everything to one side and factor and set those factors equal to 0. So we'll subtract 2x, subtract 10. This side cancels, and we get 0 equals x squared minus, negative 5 plus, 5 minus 2 is positive 3x, and then 6 minus 10 is negative 4. Factor, we need two numbers that are going to multiply to negative 4 and are going to add up to 3. So we could use 1 and 4, and we're going to use positive 4 and negative 1. So this will be 0 equals x minus 1, x plus 4. Set these equal to 0. X minus 1 equals 0. X plus 4 equals 0. Add 1. X equals 1. Subtract 4. And x equals negative 4. Let's check our restrictions. X can't be 2 or negative 5. Both of these are fine, so these are solutions. All right. So, let's see. Oh boy. All right. Last page. This one seems really easy to me. We're going to skip that one just because the video is already getting a little long, and that one's not really rocket science, so we'll skip that one. Let's do one of the really hard ones, one more difficult one, just to really make sure you can do all the hard stuff. So let's factor our denominator here. This is going to be, I'll spare you the details, but it's difference of squares. We saw it in the last set of notes. This is x plus 2 times x minus 2. So our restrictions, and you guys can probably tell by now that when it's x plus something and x minus something, it's just whatever the number is, change the sign. So our restrictions are x cannot be negative 2 and x cannot be 2. All right. All of them have the x plus 2. Oh, sorry. These two have x plus 2. So this one needs the x minus 2. This one has the x minus 2. So we need the x plus 2 on this one. All right. So let's bring this down. So this one comes down. 2x squared minus 5 over x plus 2, x minus 2. 6 times x is 6x. 6 times negative 2 is negative 12 over our matching denominator, x plus 2, x minus 2. And then 4x times x is 4x squared. 4x times 2 is 8x. Negative 7 times x is negative 7x. And then negative 7 times 2 is negative 14 over our matching denominator, x plus 2, x minus 2. All right. So now what we're going to do is we're going to combine our like terms here. So we don't have any other x squareds, so we'll just bring down our 2x squared. We don't have any other x's, so we'll just bring down our plus 6x. And then negative 5 minus 12 is negative 17 over the matching denominator equals, we can combine these like terms. 8x minus 7 is 1x. We're going to have 4x squared plus x minus 14 over the matching denominator. We multiply both sides by the matching denominator, and the denominators all cancel. And now we just have 2x squared plus 6x minus 17 equals 4x squared plus x minus 14. All right. Because we have x squareds, we're going to need to move everything to one side, and we want our x squared to be positive. So let's move this stuff over there. So we're going to subtract 2x squared. We're going to subtract 6x, and we're going to add 17. So minus 2x squared minus 6x plus 17. This cancels, and we get 0 equals 4 minus 2 is 2x squared. 1 minus 6 is negative 5x. And then negative 14 plus 17 is positive 3. Now, we have 3 terms, and we have a leading coefficient that's not 1. So we need to do complex factoring. So 2 times 3, we're going to get x squared minus 5x plus 6. We do simple factoring on this. So our factors of 6 are 1 and 6, 2 and 3. To get negative 5, we're going to do negative... No, we're not. We're going to do negative 2 and negative 3 because we need to get a positive 6. If we did negative 6 and plus 1 like I wanted, we get a negative 6 here. So it matters. So we're going to have 0 equals x minus 2 times x minus 3. We're not done with the complex factoring yet. We did the simple factoring. Now we need to go back and divide by this original leading coefficient. So we divide by 2 on both of these terms. We get 0 equals 2 goes into negative 2, negative 1 times. So x minus 1. 2 doesn't go into 3, so we move it in front of the x. So we get 2x minus 3. Now we're done factoring, and now we set them equal to 0. So x minus 1 equals 0. Add the 1 over, and x equals 1. 2x minus 3 equals 0. Add 3. These cancel. 2x equals 3. Divide by 2 to get rid of the times 2. X equals 3 over 2. So this is one answer, and this is one answer. But let's check our restrictions. X cannot be positive or negative 2. Neither of these are those numbers, so both of them are okay. All right, and there's your notes. Sorry, those ones are a little long, but it's a time-consuming process. So if you need help with that, please let me know. Hop back in the WebEx, say, Mr. Barton, please, I need help. Otherwise, have a wonderful day and enjoy your homework.